like, I guess finally we're getting back into the whole like, well, kind of. My first couple are like that. Excuse me. Why were we learning about all this natural log stuff? So the idea is, uh, uh, it's so the integral of 1 over x is the dx is the natural log of the absolute value of x plus c. Okay.
Yep.
All right, and then like in this problem here, it's really the integral of 5 times 1 over x dx, and then that 5, a lot of students like to bring it out, 5 times the integral 1 over x dx, and so you use this property over here. It's 5 natural log absolute value of x plus c. That absolute value is really, really important, but it's you got to have it in there. So any questions on that?
Nope.
All right, so the next couple of problems here are u-substitution problems, kind of. You sometimes see number 6 as like a straightforward, just natural log problem, but really, you don't know how to take the integral of this. So you rewrite it as integral 1 over u being x minus 5. You take the derivative of both sides, du equals dx, or 1 dx. So when you substitute in for dx, it's just du, and now this is something that you know how to integrate. Like, you always go back to something that you know. So this is the natural log of the absolute value of u plus c, but then you back substitute x minus 5 in for u. So it becomes the natural log absolute value x minus 5 plus c. So that's where I said sometimes you'll see reference sheets or books, like they don't differentiate between this and the previous one. It'll more generally be like the integral of 1 over x plus or minus a dx becomes the natural log x plus or minus a plus c. Because the u substitution doesn't actually add anything to it. It's like the right formality, but you get to the same place. So I don't know. It's up to you if you want to do it that way. I think it's the right way to do it. For a problem like 7, you have to use a u substitution. And you'll see why in a moment here. But then any questions on that? I don't know if that's, maybe I've made that overly complicated.
No, it makes sense.
All right. So so in this one, the u is 2x plus 5. So could you calculate the derivative of that for us, please?
So it would be the natural log of,
No, let's just, we're gonna use u substitution. What's the derivative of u over here? What's the derivative of 2x?
2
2 dx.
dx.
Root of 5 is 0. So now you solve for dx. Dx is du divided by 2. So now it becomes 1 over, instead of 2x plus 5, it's u. Instead of dx, it's du over 2. Hopefully you remember us. We did this last week, I think, right in the beginning of the week, or maybe the first part of this week. All right, so now this 1 over 2 is really, it's really a constant. The one and the 1 on the top and the 2 on the bottom. So you can actually pull that out of the integral.
Okay.
And it now becomes the natural log of the absolute value of u plus c. Bring the 1/2 down, and u is the 2x plus 5. So final answer is 1/2 natural log absolute value of 2x plus 5 plus c. And again, like we talked about the other day, you can actually take the derivative of this. Take the derivative of this, multiply by 1/2, and you get back to the original. So if you're really stuck on the exam and you don't really understand, or you just, lose interest because it's, you're never gonna use this stuff again, there are other ways to get the answer if you're stuck.
Okay.
So I'd like you to try 8 before we move on to 9. 8, I'll make a small adjustment to here. First, just pretend like that 9 is out here. So it's that way it's more like the previous problem. It's just 1/5 minus 4x dx. So you're going to make a u substitution for the bottom, just like the previous problem. You have to take its derivative, you have to put it back in like that.
Um, 9/4 integral 1/u.
Okay, but when you take the derivative of this, there's a negative.
So so negative, yeah.
Yeah, so it's -9/4 integral 1/u du.
Yeah.
Okay, so keep going. You're almost there.
9/4 natural log 1/5 minus 4x.
Right. Negative. There's a -9/4.
Oh, did
But
I not say that? Yeah.
yeah, you didn't, but again, probably you're graded on what you marked. So but I would have both as answers. Just full disclosure. I would, you know, but I'm not that I don't make tests. um, but yeah, good job. Really good. So we move on to number 9, which does not appear to be related to the others because you're like, wait, there's no number in the top, it's a square on the bottom. I made a list of like typical u substitutions. It's like parentheses, it's exponents, it's like what's under roots, it's denominators. Like there's a lot of things. So in this case, your u is the bottom here. And I said more generally, your u, when you take the derivative of u, the derivative needs to be in the integral in some capacity. So if you let your u equal x² minus 3, could you tell me du?
It would be 2x.
2x dx, good. So now I want you to rewrite the integral. Remember, you put u on the bottom, you solve this for dx, and then you try to cancel if you can.
Wait, can you say that again? You kind of cut out.
I'm asking you to substitute in the integral, substitute in u for x squared minus 3,
Oh, okay.
solve the second thing for dx, put that back in and let me know what you come up with.
Yeah. So can the x and the 2x come out of the thing like a regular number would?
Well, x cannot, but the number can.
Yeah, so like one, so we would do like 1/2x. Pull it
No,
out.
the x's cancel.
So 1/2.
Yes.
Okay.
So
So half integral 1/u du.
yes. Yeah, so what I was trying to get you to do here is see that it's du over 2x, like you said, and the x's cancel. That's the
Yeah.
whole point of this, is like if the x's don't go away, what if the x's don't go away, then you've done something wrong, or you've made a mistake. So the integral here is 1/2 natural log absolute value of u plus c. U is the x squared minus 3. So the final answer is 1/2 natural log x squared minus 3 plus c.
Yep.
All right. So that's a pretty good starter thing. Actually, all the rest are like this, believe it or not. Well, 11 and 12 are like this. I guess I want you to try, I guess 11 would be good for you to try. Wasn't gonna snip right. So let me snip. Yeah, why don't you try 11? The u substitution is the bottom, and then we'll move on to 13, 14, 15, those type, or 13 and 14, they're a little bit different.
So do we keep the top the same?
You're, it should clear out when you do your u substitution.
Okay.
So
Oh,
you have to
yeah,
have to take a leap that you're going to, it's gonna work out. That's the whole point of the u substitutions.
right. So it becomes integral 1 du over 4x to the third plus 3.
Okay, did you make your u the bottom, x to the fourth plus 3x?
Yeah,
Okay, what is du?
4x to the third plus 3.
Times dx.
Yes.
Okay, so when you solve for dx, it's du over 4x cubed plus 3. And then you always substitute in for u and for dx. So it's 4x cubed plus 3 over u. And then dx is du over 4x cubed plus 3. Do you have anything similar to this?
Yeah, I skipped a step and then that's where I made my mistake.
Okay, because these cancel, and that was the whole point, is like
Yeah,
it works out.
Yeah, I see.
Works out really nicely, actually.
Yeah. So 1/u du.
Yeah, so take the integral and then substitute back in, give me your final answer.
The natural log of x to the fourth plus 3x plus c.
Absolute value, yeah.
Yeah.
Okay. Very good. Okay, so we should look at a problem like 13
Okay.
or 14. Actually, we'll do four. I'll do 14. Maybe I'll have you do 13. So unlike the previous problems, when you like, let's just say you're like, oh, let me make the u the top, which I've never said and you rarely do, but let's just say you'd make it the top. The u is 3x squared minus 8 times dx. Is that in the integral? Do you see a 3x squared and a minus 8 over here?
I see a x squared.
Yeah, but no like minus anything. So this is wrong. Um, you might think that okay, well, let's make it the bottom. Well, du is 2x dx. That's not great either. So sometimes we miss the obvious thing here, and that's so like the more integrals you do, the more you're like, oh, I like sometimes like you forget. Trying to think of a good example in real life. But sometimes we make things harder than it is. You just need to divide both of these by x squared. So this becomes integral x minus 8 over x. And again, no calculus has been done. This is just a rewrite step.
Right.
Okay. So now it's much more doable. Okay. If you need to, you can separate them. It's x dx minus integral 8 over x dx. The first one is power rule. Right? What's the antiderivative of x?
Uh, so it would be x to the 1 plus, so it's x squared over 2.
It's some variation on 1/2 x squared. We've got a bunch of these now. What's the integral of 8 over x? It's like the first problem we did today.
Um, 8 integral 1 over x.
Right? So what does that become? You can bring the 8 out if you want, but what does that, keep going.
So it's a natural log of 1 over x.
It's not natural log 1 over x. What is the natural log of?
Absolute value of x.
Yes. Plus c. Any questions on that?
Nope.
All right, why don't you try 13? It's really, really similar. Some ways it's maybe easier, but it's really similar to the one we just did. So why don't you try that? Ask me some.
So it becomes integral 7 over x minus 1 over x dx.
I may have heard something different. Let me, like, it becomes x over 7 minus 1 over. I'm not
Yeah,
sure
that's
if
what
that. Okay,
yeah,
okay,
that's what
okay. All right, great. Now keep in mind this one over here on the left, it's really 1 over 7 times x.
right.
So try not like it. I don't know why the brain does this, but it like sees things that aren't true. Like the first one is power rule, not natural log. The second one is natural log. Go ahead and I guess keep working this one out, please. I'm gonna step away for 30 seconds. I'll be right back.
Yeah.
All right, I'm back. How are you doing on this one?
Okay, so we have to pull out the 1 over 7 and
You
then
you can't. I mean, you don't have to. You can just leave it in there. But yeah,
x dx minus natural log of x, right?
what does this first one become?
1 over 7 times x squared over 2.
Okay, good. So it becomes x squared over 14
Yeah.
like that. Let's see. So unfortunately, your class has kind of done you a service by not like I usually work with students where I give them problems like, you know, integral of like 2 plus 2x plus x squared. Because I really want you to be able to work through all the iterations of this to be able to like be comfortable, like what are, because these are all different, but they're all in the same general category of polynomials. So like the integral of a constant is 2x. when you have x, you add 1 and divide by the new exponent. Same thing over here for the last one. So like for your test, you really want to get clear on this. So this is 2x plus x squared plus 1/3 x cubed plus c. And then what happens is, and again, I don't understand the brain. I don't know how the brain actually works, but it's like for some reason, x over 2 plus 2 over x looks the same to students, and they're very different. The first one is really 1/2 x to the power of 1 integral. Second one is 2 times 1 over x. The second one is the natural log of the absolute value of x times 2. The first one is the power rule that we've been using over and over and over again. And like somehow you have to convince yourself that they're different, they're not the same. Just be very careful. It's so easy on tests to, like, the way the brain works is like if you do 2 things in a row the same, the third thing you try to do the same. And teachers know this, so they create problems like that. All right. We should move on to the next page here, like 23 maybe, 24. I'll do 24. By the way, one of the side effects of living at home, just share a brief story here to kind of break up the time here is, I don't know if you have any pets. I think you mentioned a dog, but like I used to notice like the pets could like hear cars coming up. The more you live like alone, you're tuned to like what's going on. Like you hear cars coming up the street that you wouldn't normally hear. It's kind of an amazing thing, like what your senses do when you allow them to focus on things.
Right.
So yeah, whatever. Yeah, so actually this one's got a lot going on. This isn't the best example. Let me I'm gonna do 23 and we'll maybe skip because I was really thinking that this is the better one to do, I guess. All right, so there's exceptions to everything in life, and this is one of them. Like normally u is the bottom, but this time u is actually what's in parentheses. Like we haven't done one like this, so how would you know? Well, uh, yeah, if you're that type of student that's really like wants to seek out these things, you might try a bunch of things, but it is frustrating. Like if you choose the wrong u, you never get the right answer. So du is 1 over x dx. So this time when you solve for dx, it's x times du because you're multiplying both sides of this by x. You get those x's to cancel. So that's interesting. That's different. We haven't seen that before. Usually it's du over something. This time it's x times du. But just like before, you always substitute in for u, meaning like whatever the u was. So it's u squared over x. And this time it's x times du. But notice it's the same net result. The x's cancel.
Right.
So your u is not always the bottom. Sometimes it is. So this becomes the integral of u squared du. And now it's just power rule. So every integral we've done today it's always going to be something better. So what is the antiderivative of this?
U to the third power over 3.
Yes, it should always be something better, simpler. And then you say, okay, your u is really natural log of x. So it's natural log of x to the power of 3 over 3 plus c. Any questions or thoughts on that?
No, that makes sense.
Okay. All right, let's look at 25. All right, so 25, just give me your sense of what the U should be in this problem.
1 minus 3 square root of x.
That is correct. So your du, this is where, you gotta be really good with your derivatives. It's -3 times the derivative of the square root of x. And I've said a few times, like, it's really a lot better if you can write it this way rather than doing the whole power thing. I know
Right.
they don't emphasize that, but it really does save you some heartburn when you're doing these problems. So they get kind of awful. Um, so now, sorry, and there's a dx here. So now dx is 2 square root x over -3 du. You just multiply both sides by the reciprocal of this. That's why the 2 square root of x is on top and the -3 is on the bottom.
Yeah, that makes sense.
And then you go back here. Okay, integral 1 over. We don't have anything for the square root of x, but we do have it for the 1 minus. So we do that part. Then dx. So dx is 2 square root of x over -3 du.
So then do the square roots cancel?
They
then?
do. And that's the whole point of these u substitution problems, is like you have to get rid of the variables. The numbers are okay. If you want to keep, the numbers in there, that's fine. So it becomes 2 over -3, or -2/3 integral 1 over u du. So from here, could you finish off this problem for us?
So it becomes -2/3 natural log of 1 over, what was the starting u value? It was 1 minus 3 root x.
Okay. Yeah,
Plus c.
like that. Okay. All right. Why don't you try 26 on your own? It's really similar. This time you will keep the exponents as numbers, but you should see effectively the same cancellations when you do it like this.
3 natural log of absolute value 1 plus x to the 1/3 plus c.
Right. So like, as I mentioned before, and this will help you on your test, like I'm just going to take the derivative of this and see if it's right. 3 times 1 over 1 plus x to the 1/3. The derivative of the inside function is 1/3 x to the minus 2/3. And here's the good news that you've done this correctly. This cancels with this, and this goes to the bottom. So it becomes 1 over x to the 2/3 times 1 plus x to the 1/3. Like that, and you've done it. So you might feel like, oh, I got it. Like I don't need to practice these, or feel like the thing is they're gonna be all mixed up. It's not like it's easy when they tell you like, yeah, we're all in the natural logarithm section. But you're not. There's more.
Right.
There's more here. So, oh boy. These are not the right problems to start with. Okay. '27 leads to this new type of question that it's really miserable. I'm surprised they didn't give you kind of a different one here to start with. And then 29 through 32 are kind of in the same group. Just trying to see if there's any others that are like that. I don't know. I mean, we don't have time to get through all of this. So is there like, do you want to pick out specific problems you want us to do? The last, 10 minutes we got. 27 starts a new section, but then like 51 starts a new, it's kind of related to what we've been doing. It's just with definite, it's a definite integral with bounds, but what would you like to do here with our time remaining?
One from between 27 to 32 and one from the 50s group, 51 through 55.
Right. You might have to repeat there. We'll start with this one. So what does your intuition tell you that the U is in this problem?
X minus 5.
And you would be correct. So du is dx integral 6x over u squared du. And it's like, oh no. The x is still there. And this is where someone has to come in and tell you, like, you don't have like you wouldn't know this until you've seen it. So, and that's why I said like everything we're doing like works a lot of the time and all the time. So we've never done this before, but you can take this equation and you can actually solve for x. So x equals u plus 5. You're like, why would you do that? Well, because there's an x still in your equation. Now you don't do this in all the other ones we've done, but it does work in this type of problem. And so the big part of calculus 2, which I know you're not taking as far as I know, is identifying this type of stuff. So you may or may not think this is actually better, but it is. It's better when you have a single term on the bottom because you can divide it. Whereas in the original you do have a single term, but it's a power, things like that here. So the 6 can come out. And then it becomes u over u squared plus 5 over u squared du. Do you follow what I've done there? Is that okay?
Yeah.
So it becomes, again, still haven't done any calculus, 1 over u plus 5 times 1 over u squared, integral 6 du. So the first one is 6 integral 1 over u du. The second one is 30, 6 times 7 is 30, integral 1 over u squared du. 1 over u is the natural log absolute value of u times 6. Now this one we haven't seen in a while. This is a power rule integral. It's really the integral of u to the minus 2. So it's add 1, divide by the new exponent. So it ends up being negative 1 over u. And that is the antiderivative. Like you don't have to take the antiderivative of this, the integral of this. So it's 6 natural log absolute value u minus 30 over u plus c. And then you got to go back and remember what was my u? And because your answer will never be in terms of u, or it shouldn't be. So it's 6 natural log absolute value x minus 5 minus 30 over x minus 5 plus c. And this is the first type of problem where you probably couldn't take the derivative of this and really see that it becomes this. You might see it, but you couldn't guarantee that. So again, that technique doesn't work for everything.
Okay, that makes sense.
All right, so I mean, why don't you look at 33 through 38? If one stands out.
Maybe like 38, I guess.
Okay. All right, it's 38. Two things here. We got the integral of 2 d theta minus the integral of tangent theta over 4 d theta. What's the integral of the first one?
Two integral theta.
So remember, when you take the antiderivative integral, like there's no more integral symbol. Like what's the net result of this when you're all done?
Oh, 2 theta squared over 2, or so theta squared.
There's no variable here. That's that. Like if you remember earlier, I was trying to show you this. Let me find it here. Way up here. Like you're still not clear between the difference between the integral of a constant times a variable to a power. Like you have to get, if you want to be successful in this course, you have to get really confident on these and like, bam, bam, bam. Like, so this one is just the integral of a constant. The integral of a constant is 2 times the variable, or the constant times the variable. Now on the right here, we're going to make a u substitution. U is theta over 4. Du is 1 over 4 d theta. D theta is 4 times du. Tangent of u, 4 du. So this becomes 2 theta minus 4 integral tangent u du. And this is one of those that I believe is on your reference sheet. There's so many of these that you have to, as a student, you have to remember. As someone who doesn't need to remember this, I just go and look them up. So the integral of tangent, it's a whole nother part of that reference sheet. It's not, it's a lot. The integral of tangent is minus natural log cosine of u, or natural log secant u. So I don't know which one would appear on your test. That's that's, you got to know both, I guess. So good to have that on there. So this becomes 2 theta minus 4. And I'll use this one here. So it's plus 4 natural log absolute value cosine u plus c. U is really theta over 4. So it's 4 natural log absolute value cosine theta over 4 plus c, 2 theta plus, like that.
Okay.
So in some ways the course like get really hard here today. Like it was like a lot to think about. In this last grouping of questions here, the only difference between these problems and kind of that first grouping we did today is that these have bounds. So instead of it being plus c, you end up evaluating at the lower and the upper limit. So in some ways these are easier because you get numerical values potentially, but couldn't say All right, well, we're gonna go ahead and stop here for today.